a helicopter is flying with a constant horizontal velocity of 180 kilometers per hour. So constant horizontal velocity. So there's no forces on the horizontal direction. And is directly above point A when a loose part begins to fall. The part lands 6.5 seconds later at point B on an inclined surface. Determine the distance d between point A and B and the initial height h. Cool. So this problem is very similar to the previous ones that we did in here, because once again we have something that is detaching from a flying vehicle, and we know that when it detaches, it doesn't have any forces pushing it on the horizontal direction, and it has gravity pushing it on the vertical direction. Now let me go ahead and close off this triangle here. Let's try to make a straight line here. Not the best at this. Okay. And also let me try to close a straight line upwards too. Okay, so note that I just completed a triangle. This triangle has the angle of 90 degrees here. Okay, and I'm going to call this part of the triangle X over here, and I'm going to call this part of the triangle Z, and this part of the triangle here is part D, right? As you can see from the drawing. So it's this guy here, D. Cool. Now, what do we know? We know that if we look at the, once again, if we do a little control volume, only on the part that detached from the helicopter, we're going to have a original velocity on the X direction, and we're going to have no velocity, so v naught y equals 0 on the y direction, right? So when the thing begins to fall, because it's on the helicopter, hopefully the helicopter is not falling down, so it doesn't have any velocity on the y direction. And on the x direction, they gave the information that it's 180 k's per hour, which if we convert, divided by 3.6, we get 50 meters per second. Brilliant. And we know the only force acting upon this loose part here is actually gravity, right? So the only force is force of gravity, so we're going to have acceleration due to the force of gravity. Brilliant. Now, what do we need to do? We need to find, what are the two things they're asking for? We need to find D and H. Okay, so to find D, that's very straightforward. All we need to do is use this angle here that was given, and this distance Z here that we can find easily because we know how fast this thing is traveling and how fast it's going to travel for. Okay? So if we have that angle there and Z, then we can use those two to find D. Right? We know that the part that detaches from the helicopter will travel with a constant speed on the x direction for 6.5 seconds. Right? That's the time it has to travel on the x direction before it lands. So, in other words, I can say, I can do a couple of things here, right? First thing I can do is the cosine of not theta, sorry, cosine of 10 degrees is z over d, right? By definition. And likewise, the sine of 10 degrees is x over d, again by definition. Cool. So what I need to do is find z, and I can find z because I know the initial velocity of the part, and I know there's nothing messing with that velocity, right? So because, let's put it like this, because the acceleration on the x direction is 0, it's nil, then we can go ahead into just velocity is how position changes with time, and therefore my vx times my t will be equal to my delta x, and this delta x is precisely the z that I drew on the triangle. I know this guy is 50 meters per second. I know the time that it has to travel is 6.5 seconds. So seconds and seconds, and this gives me 325 meters, which is equal to z. Right, so if that's true, if that's equal to z, then all I need to do is grab this correlation here with that triangle from the beginning over here. And if this is true, then it means that cosine of 10 equals 325 divided by d, and therefore d is just 325 divided by the cosine of 10 degrees, which is about 330 meters. So that's the answer for part A of the problem. What is the distance d? Now for the h, which is the next thing they're asked us, this distance here, well, to do that, all we need to know is that the total amount that the part falls, and we can follow this trajectory to see the total amount on the y direction it falls, is from, let's get a green color here, from point B all the way to the original height of the helicopter. Right? So in other words, the total delta y of this problem is the h plus the x. Right? So we can do, because we know all the information on the y direction, like we knew on the x direction, we can use that to calculate what is h, right? So let's go ahead and do, let's do it with blue. B. We know that vertically our v naught is 0 and our acceleration is gravity at time equals 0, right? So before the thing starts falling. We also know that the gravity is not going to change with time. Okay, so we're assuming that, and there's no air resistance. So we can go ahead and do, well, we can do each step at a time if you want to, but the idea here is that I'm going to have acceleration is how my velocity is changing with time. So I can integrate the t on one side because my acceleration is not changing. I'm going to have at v naught. V naught is nil, right? V naught is nil, so therefore my acceleration squared over 2 equals the delta distance. I should probably do one more step before I jump into here. So at, I can sub in where I have velocity. I know how velocity is how my position is changing with time. So now I can integrate with respect to time on the left hand side and respect to y on the right hand side. So this is going to give me at squared over 2 and delta y. So I'm integrating from y naught to y and from 0 to t, t being the time in which it lands. Brilliant. And then from here, this delta y is the thing that we actually defined just before, right? So this guy here, this definition that we did before. So we can copy this and paste it down here, and we can combine this information. So we can combine these two guys here, and note that the acceleration time squared over 2, that's to be equal to h plus x. Now we can sub in a bit more things because acceleration is gravity, time is 6.5, that's how much it has to fall, and x we can calculate using the sign equation, right? So let me go ahead and grab a sign identity that we wrote before. We put that over here to remind us of what we're doing. Okay, so I'm going to combine these guys here to say that g times 6.5 squared, g be 9.8, you go and do 9.8, it's fine, 9.8 equals h, which is what we're looking for, plus x, and x is just d times the sine of 10 degrees. So note that the only unknown that we have here is h because we defined d, and d was 330. Right, so this is 330. Okay, so therefore h is, what did I get? 149.9. 149.9 meters. That's the height from where the helicopter is originally, and the part falls off, to 0.8, which is directly below the helicopter where the part falls off, right? So this height here. Cool. Questions on this one?